All right. I hope you guys are happy. We're only going to spend one day on this activity. Let me tell you why. The hardest part about modeling and optimization is creating a model. And guess what? The AP exam is not testing to see if you can create a model for the most part. They usually will give you the model, usually. And then from there, that's what you optimize. Chav, I don't know what you're talking about. Remember all this time we've been finding max and mins? Now we're gonna have a situation and they're gonna ask you what's the maximum amount of time that you can blah blah blah. Or what's the least amount of area that takes up for blah blah blah, whatever it is. See? Let's just look up optimization of what's the least amount of surface area or material that I can use to have the biggest volume. See? So now we're using application problems to figure out a model and to do a derivative to see the max and mins. Does that make sense, guys? Okay. So don't worry. So look what I guess let's read this. So let's do a simple one first. We were talking about derivatives to find max and mins. Now it's time to some applications. Let's look at a question we had when you were in algebra 2 and see how we can do this with this question with calc. Find two numbers whose sum is 20 and whose product is as large as possible. Okay, so I'm going to write two numbers, so x plus y, and the sum is 20. Sometimes this is called the restriction equation. Restriction equation. And whose product is as large as possible. So product equals x times y. This is what we want to maximize. What we want to maximize. So because this is what we want to maximize, that expression is what I'm going to be taking a derivative for. And whenever this derivative changes from positive to negative, that's going to be where it's the biggest. Does that make sense, guys? Okay, now you see how you have two variables right now? You don't want two variables. You just want one. So that's where the restriction equation comes from. Why do you guys look sad? You guys looked really happy a little while ago, and as soon as we start talking calculus, you guys went from like, and then you're like, relax. It's guys, this is life. We have tests all the time. Oh, I'm sorry, guys. Look, your feelings are valid, but if our biggest problem, yeah, if our biggest problem in our life right now is worrying about grades, then I say we have it pretty good. We have air conditioning. We're not barefoot. We're not hungry. We're not, like we have electricity. Like we got a lot of, you got health. So we got a lot of things to be thankful for. So, well, I hope get some help, please. But like in a good way, with love. I'll take my own advice. I'll start exercising, just not running. But yeah, no. That's, the run club is the last thing we want. But I'll walk. I don't mind walking. But yeah, I'll take my own advice. Make sure that everyone is healthy. No. Let's not do that. All right, here we go. So you see this restriction equation? I'm going to use this to plug into my x, y here. So I'm going to take that. I'm going to say y equals 20 minus x. And now that I know that y equals 20 minus x, I'm going to use that to substitute into my product here. P equals x times 20 minus x. See? And now I can just distribute, and I get 20x minus x squared. Now I'm going to take a derivative. So I'm going to write p prime because I'm trying to find the max. That's what we're going to do. See, we want to maximize. We want to maximize. So I'm just finding a max. Finding a max on p. So I'll take a derivative. So the derivative of 20x is 20, and the derivative of x squared is 2x. I'm equal it to 0 to find a critical number. I get 2x equals 20. I get x, semicolon, x equals 10. If I do a sign chart, and I'll slow down. What's up, Morales? No, your goodness. If I do what's up? Oh yeah, you're right. That's P prime. What's up? Wait, you said I can't read. Finding a max on P. Okay. because that's what I want to maximize. You know what I mean? So all I'm doing is finding where P prime changes from what to what? Positive to negative. So check it out. If I plug in a 0, I get positive times a positive, which is positive. If I plug in a number bigger than 10, like, I don't know, 11, 12, whatever it may be. Let's see, where's my P prime? Right here. If I plug a number bigger than 10, like 11, 2 times 11 is 22. 20 minus 22 is a negative. So there it is. So P does in fact have a max at 10. So find two numbers whose product is the largest possible. Okay, so my two numbers, man, I'm running out of space here. I'll do it in black. My two numbers that give a max product. They give a max product are x equals 10, comma, y equals 20 minus 10, 10. Yeah, of course, it's a square. So there it is. Chav, how would you have done this when we were in Algebra 2? When you were in Algebra 2, you probably just wrote this in there. Let's see, you probably just wrote this expression, 20x minus x squared. So look, here it is. Y equals, or x times, what was the other one? 10 minus x? X, 20 minus x. There's my product here, right? X, y. And then look, I already know the max is in 10, so I'm going to go 0 to 20. That's my sum. And then what's 10 times 10? 100. So 0 to 150. So I better have a peak at x equals 10. Here's my product. And check it out. There it is. Second, calculate max number 4. There's just that expression. X left bound. I want it to look between here and here. I'm just sending the calculator to do it for me. And don't worry, I'll answer questions right now. And check it out. 10.00. There's some tolerance going on there, but that's X value of 10. And that's how you would do it in algebra when you were in algebra. You guys remember that, guys? All right, okay. Well, maybe you don't, maybe you don't. But the concept was, you didn't do that in algebra? Oh, sorry. Well, someone had a question. I saw a hand go up. No? Am I seeing things?
Okay, question.
Yes.
So essentially, if say the number wasn't 20, it was a different number, like 15, where it isn't divisible by 2, what would be the steps for that?
You can leave it as 15 over 2 or 7.5.
Okay, so it would be the same thing, like you would subtract whatever you get for x from y, from whatever we had.
Mm-hmm. Okay. What's up? Did they want the product? I thought they just want find two numbers. Yeah, the max product is 100.
I could see this and I know it. This is a calculator. It didn't say y equal 100, so I think I'm just assuming that.
No, that's y is the product. Why? Because p equals x times. I guess I didn't have to put this one in. I could have just put this one in, but I just put x times y. This is your y. You know what I mean? Not that the y was p in our calculator.
No, I think I just saw it. Just got
Yeah, my bad.
So for p equals xy, that's the equation for product?
Yes, right here. See? And because that's what they wanted, right? Whose product is the largest possible. Now, they didn't tell me find the largest possible area. They just said what's the what largest possible product. They just said find two numbers. So they just wanted the numbers, x and y. What's up, Houston?
If we were able to conclude that later.
I'll ask. Sometimes, guys, and I guess we'll talk about it now. You see how I don't restrict. I mean, you can choose any two numbers, even the negative numbers you can choose, as long as they sum up to 20. Sometimes your professor will say, use the second derivative test to prove that this is the max. So remember what the second derivative test is, that if you have a critical number of 0 and your second derivative is negative, that's how you prove that it's a max. Chop, how? If your second derivative is negative, that means that the original answer is concave down. And if you have a critical number on a concave down, it has to be a max. Does that make sense? That situation does come up here. I was going to do it last, but who knows? Maybe we'll do it tomorrow because I want to make sure that we understand like this first. You know what I mean? So check it out. Look at the next one. This one's very common. I have seen this one, an easier one, but I have seen it on the AP exam. Remember, the hardest questions are here. So a rectangle is inscribed under an arc of the sine curve. Okay. What is the largest area the rectangle can have, and what dimensions give you that area? Okay, guys, what makes this question hard is creating a model. I've seen this question on the AP exam, but it's easier because they usually give you the model. So let's do this real quick. A rectangle inscribed under an arc of a sine curve. Does everyone know how y equals sine x looks like? We all had pre-cal, right? Sine x goes through the origin. So here's sine x. Here's the max is a 1 for the y value. And it crosses the x-axis at 0 and then again at... What's the next one? What's this coordinate? Pi. Yay or nay? Okay. It's telling me a rectangle is inscribed under one arc of the sine curve. Okay. I have a rectangle. Bam. And to make life easier, how do I make life easier for us? It's a metric about x equals pi over 2. Are we okay? All right, so I'm going to call this curve y equals sine x. This is not the only way to do this. This is just the way I do it. And I'm not saying that my way is the best way, but if you see logically, if you think look, I haven't done this in a long time, guys. I'm just doing it with logic. I want to, what do I want to find? What is the largest area the rectangle can have? So I need dimensions, right? So here's what I see. When I do this in my head, I'm like, the distance between here, the origin at 0, and let me change the color. From here, 0, and this guy right there, that gap right here that I'm doing in purple, that is just some x value, right? And because I'm symmetric at the pi over 2, if this is some x value, then this distance right here is some x value. Does that make sense to you? So in my head, I'm like, okay, the area of this rectangle, this height is just dictated by this curve. Look what that curve is called, y. So I'm going to put y for the vertical. Yeah. So my area is going to, perfect. It's going to be y times the distance from here all the way to here is pi. And I subtract what? Not 1x, but 2x's. Do you guys see how I did it? So that's the hardest part, creating the model. Chop, I want to understand the model. What am I trying to find? I'm trying to find, does everyone know that area of a rectangle is length times width? Yes. Okay, so I know that this height, if you want to call the height width, is just y. So this is my y, here's my height. Now to get the width, the distance from this rectangle right here, well, the distance from here to here is pi. This is an x, just some x value. It's symmetric right at pi over 2, so this has to be that same x value. Oh, okay, so this distance here is pi minus, how many x's do you see? 2x. And that's how I get that width, or whatever, the length or whatever. Does that make sense? So there it is, guys. This is why this is so hard. Now, I don't want the area in terms of two expressions. Good job, Miss Houston, future engineer there. I want my expression in terms of just one variable. What does this y equal? So there it is. I'm going to plug that in there. So I'm going to write area equals sine x, parenthesis, pi minus 2x. Close it. Mr. Chavez. Hello. I do. Oh, bummer. Okay. Bye-bye. You leave. Don't worry, miss. I'll record this. Okay. You're probably going to have a lot of fun. You're going to eat some breakfast? I'll stop. All right, I'll tell you since I already started talking about it. If you guys ever decide to leave school, like this class, you have free will, right? But if you decide to go, I would make sure that you really take advantage of it by going to have bomb breakfast somewhere. Sorry. That's what I would do. Sorry. You don't have to go have breakfast. But if you do, make it a good one. Okay. Sorry, miss. I hope I didn't offend. Okay.
So for y equals sine x,
Later, miss.
That's just the slope of that line?
The y equals sine x, that's that's the equation of this. And all I did was I replaced y with sine x, right? Because that's how you find this height of that rectangle. And then height times length. I'm going to distribute this, guys, like this. Because it's easier for me, I think. You're still gonna have to do product rule, but let's see. Pi sine x minus 2x sine x. I guess. It doesn't matter how you cook it. We're gonna have to do product rule, and we're gonna have to use the calculator. There's no way around it. But it's not extreme. You know what? We'll just use the calculator since we're gonna use it anyways. So let's show you how to use the calculator. Ready? Does everyone have a calculator? So take your calculator and type this into y1. So I'm gonna go type into y1. Later on, we'll use Desmos once we start, getting ready for online exam. So here we go. Second memory 712. Reset them. Reset the calculators first because there's a lot of junk in there from the pre-calc. They might be in degrees and stuff like that. So second memory 712. And then in the y1, I'm going to type in pi sine x. Oh, the memory is a plus button. Pi sine x plus, minus 2x sine x. Minus 2x sine x. Okay. Turn off y1. Chav, how do you turn it off? Hover over the equal sign and push enter. And then go to y2 and push math, numeric derivative number 8, and then put x, and then put alpha trace y1 at x equals x. Now let me know what you need help like plugging in. Yes. So I'll even do it one more time. So I'm going to clear this. So here we go. Push math, numeric derivative number 8, and minus number 8. X, and then in here you type in y1. How do you type in y1? Alpha trace, and there it is, all the y values that you can put in there. Put y1, and then put x equals x, like that. Cool or not cool? Okay, now push window. You're only looking between 0 and pi. As a matter of fact, if you want to make a case, you can. You're only looking, what's the biggest x can be? So you make a restriction between 0 and pi over 2. So 0. If you're at any of those extremes, you don't have a rectangle, right? If you're at any of those extremes. 0 to pi over 2. X scale, pi over 4. Half of that.
Wait, why did we put pi over 2 on the x?
Because if you're at pi over 2, you don't have a rectangle. See, like, let me show you. What's the biggest that this x can be? What's the biggest that this x can be right here? Well, if you max it out, I guess.
Oh, okay, I understand.
And then for y value, guys, you can put like negative 0.5 and 1. It's probably going to be a lot less than that, but what's up?
What do you put for x scale?
Pi over 4. It doesn't really matter for x scale.
And then y scale 0.5.
0.5 if you want. Yeah, if you want. You don't have to. X resolution, leave it like this. Don't mess with the delta x and then trace step. All right, check it out. There it is. Look at that value. What you're looking at is the derivative. So wherever the derivative changes from positive to negative, that definitely is a... let's start again. When the derivative changes from positive to negative, that means that is a max on my original. Does that make sense? All right, so I'm going to tell the calculator to find that 0. Second, calculate number 2, 0, and then left bound to the left, right bound to the right, enter. And then when it says guess, just push enter.
What do you mean quit? Sorry, my calculator is
Yeah, I think... Say it again.
the window.
Window. 0, pi over 2, pi over 4, negative 0.5. I made my y max 1. Okay, I'm going to do this again. And by the way, guys, just a conversation real quick about this. Whenever you have a restriction, see how the x has to be between 0 and pi over 2? then if you find a critical number, that critical number has to be a max because at the extremes you have no rectangle. If you're at 0, well then you have no rectangle. You know what I mean? If you're at 0.1, you have a very, very small rectangle or height-wise, but very long. Does that make sense? If you're like 0.1 away from pi over 2, then you have a very slim rectangle, but very tall. Does that make sense? So if you're at the extremes at 0 and at pi over 2, you have no rectangle. So if we get a critical number between 0 and pi over 2, that must be a max. It must be. It's as evident here by max positive to negative. Okay, does everyone know how to find that 0 there? All right, check it out. I want to make sure that you guys know. Second, calculate number 2. And then when it says left bound, you go to the left of that 0. When it says right bound, you go to the right of that 0. Guess, just push enter. Now, I want you guys to know how to, don't yawning, that's a demerit. I want you guys to know how to store that number. You see that 0.7104628? Go to the home screen. Second, quit. Push the, right now, the industry calls it registers, the programmers. I don't know if that's a programming thing. Right now, it saved as the X register. So if you push X, right next to the alpha, and then push the stow button right here, so we're going to store it in a variable besides X, because that's the last one you want to put it in. I like to go by the alphabet. So what's the first letter in the alphabet? So there it is. I stored it to A. And then check it out. There it is. Cool or not cool? I'll say you can do. This is why I like the calculator over Desmos. You can do it with Desmos, but I think the Desmos that you have on AP testing, I don't think you have the copy paste feature. So you might, for the AP. You know what I mean? That's why I prefer a calculator because now you can. You know what I mean? Okay. All right. So here we go. You can also do this on Desmos, guys. It's just you don't have the full Desmos on AP testing, but for the regular Desmos, you do. It works the same. You can also store it. All right. So here it is. I'm going to say. I'm going to go A prime equals 0 when X equals, and I'm going to say what number that was, 0.710462. The more digits, the better. 0.71, I already forgot it. 0462. Give me more digits if there's more. Is there more? 8425. And I'm going to put an arrow, and I'm going to put capital A. So that means I stored it in A. What did they want? They want the dimensions. What is the largest area a rectangle can have? Okay, I already got it. So, by the way, you know what we should also say? We should also say, make a statement and say, A prime changes from positive to negative at this specific X value, semicolon, meaning max area. Max A. Max area. That way we don't get confused with the A and the area. We're still okay? All right. Let's find out what the max area is. Don't worry, I'm slowing down. You don't have to do anything by hand, guys. Area at 0.71. You can actually put area of A, but I just don't want to have two A's in there. 0.7104628425 equals. Go to your calculator, and we'll go slow. Guys, don't you guys already have the expression for area in Y1? Just call Y1 in the home screen. Go like this. Go alpha trace Y1. And don't you already have the X value stored in your calculator as A? Open parenthesis and put what? A. And now when you push enter, voila, that's the max area. 1.12219. 1.12219. Do they also want the dimensions? What are the largest area rectangle can have and what dimensions? Yep. And then I'll put and dimensions are. Okay, so let's do the height first. The height was just y equals sine x, right? So I'm just going to put sine of A. So I'm going to write sine of A, alpha A. 0.6521, truncated or 22 rounded. 0.6521 by, and let's see the other one. What was the other? What was my pi minus 2x? Pi minus 2a. Pi minus 2a A. 1.72066.
Have we got that from the formula?
Yep. Oh man. Nice area. By 1.72066. Child, how is the lanes bigger than my max area? Guys, if you take this and you multiply by this, you're going to get that number. So look, if I go that times this, voila, 1.122. Cool, right? Everything makes sense. Everything makes sense. I think we got it. Max area, there it is. Square units, there's no units here, but square units, dimensions are blah by blah. Whew, I'm sweating, guys. It's too hot in here. Are you guys sweating? Man, this is me running right now. Okay. How do we feel? Well, let me slow down, guys, because I wanna relate it to something. Do you guys have a bottle here of water? Here, let me that. Don't worry, I'm not gonna drink it. So, when do they say? Have you ever seen a water bottle that says, "We're saving plastic, we're saving the world," like a new smaller bottle, blah blah blah, whatever? Guys, that's calculus in motion. Whenever they design this to hold the most water with the least amount of plastic. Now, do you think these companies are driven by, they want to save the environment? Or what else do you think? If they use less product, that means more what for them?
Money.
More profit, because they're using less. So this is calculus in motion. Look at all these little grooves. You think like they just, let's put these grooves in here so it can fit better in the hand. Maybe, but there's more to it than that. You guys know what I mean? See? So all this stuff that you're seeing, all of this, like it's like obviously like they didn't like they use obviously software, some CAD model, but that's what they're doing, guys. The smaller the surface area, and they're trying to figure out what's the smallest surface area I can do that holds the most liquid. See, like you know what I mean? Like, and they create models, and of course, if you have AutoCAD, it tells you about the density. Sorry, Miss Houston. Okay, so check it out. So let's read this real quick, and then we might stop after this one. Let me see. Yeah, because maybe the next stuff. We might do one more question. There's a business calculus question there. All right, let's read this together. To optimize something means to maximize or minimize some aspect of it. What is the size of the most profitable production run? What is the least expensive shape for an oil can? What is the stiffest rectangular beam we can cut from a 12-inch log? We usually answer such questions by finding the greatest or smallest value of some function that we have used to model the situation. That's all this is, guys. See, this is why, Chubb, how is math going to be important? You use math to model. And when you go to engineering school, you're going to be working with models all the time. So here it is. Here's an example. We're babies. We're rookies. So we're just going to do a simple one. There is also something, you got to take waste into account. But right now, let's just make the model simple. You okay, Fab? Okay. So here, check it out. An open top box is to be made by cutting congruent squares of side length X from the corners of a 20 by 25-inch sheet of tin and bending up the sides. So here it is. How large should the squares be to make the box hold as much as possible? What is the resulting maximum volume? Guys, relax. There is also something called waste that you got to take into account, but we're not doing that right now. So what do they want? It's say, how large should the squares be made to make the box hold as much as possible? Okay, so I want max volume. Do you guys see what the issue here? So all I know is that I have 25 by 20. So here it is, 25 inches. By the way, when you see double quotes, that's inches. When you see a single quote, that's feet. So just something for you to be aware of. So 25 inches by 20 inches. So there's my sheet, and they're just cutting these corners. And when you fold up these corners, you get a box. And check it out. Here's my box, and it's an open box. I think they also tell you that in here. Yeah, open top box. Do you guys see that? All right, so they want me to figure out a max that I can do to cut these X's that will give me the biggest volume. Cool or not cool? All right, so first I got to figure out my volume expression because that's what I want to maximize. So let me write that down. We want to maximize or max. We want to maximize volume, comma. So we need an expression for volume. Are we still okay? Volume equals, all right, here's my box. How do I find volume of a rectangular prism or of a box? Just multiply length times width times height, right? So x times 20 minus 2x times 25 minus 2x. Are we still okay? Now there is something called a triple product rule, but we're not taking calculus honors. If you decide to take calculus honors at the university, they'll probably talk about it, and you'll probably do a lot of theories and derive stuff by hand. Let's just multiply this so we can. This is what we want to derive, so that's what we're going to take a derivative of. But we don't want to take a derivative right now. So let's go ahead and expand it, get it into a polynomial, and then once we got a polynomial, we can just take the derivative. So the way I see it, I'm going to do it like this. You see that in brackets? I'm just going to FOIL that, and then whenever I got an expression, I'm going to distribute the x. Does that make sense, guys? Okay, what is 20 times 25? I want to say that's 400. Okay. The only reason I know that is because if you have 20 quarters, that's... Oh, if I have 25, if I have 20 quarters, that's $40. Damn, 500, $5. Damn, I'm gonna delete that from this video. $5. All right, so there it is. 20 quarters, $5. 20 times 25, 500. 20 times 2x, 40x. Yeah, negative. Negative 2x times 25. Perfect. Negative 2x times negative 2x. 4x squared. Close it. You usually like to have the highest power first. So now I'm going to distribute the x. And I'm going to combine these two right here. So here's what I have. Volume equals 4x cubed, because you want to have the highest power in the beginning, minus 50 plus 40 is 90, but it's still negative. So minus 90x squared plus 500x. Did we do everything correctly?
Can you distribute out an x?
Can you what?
No, that's never.
Okay. You're good. Okay. What do I want to maximize? So that's what I'm going to take a derivative. And I'm going to look where the derivative goes from positive to negative. Well, actually, okay, we'll talk. We'll talk in a little bit. So here you go. V prime equals the derivative of 4x cubed minus plus, and I'm going to equal this to 0. All right. Before I continue, here's my restriction. What is the biggest x can be? So focus on that one and focus on that one. What's the smallest x can be? X has to be between 0 and... What's the biggest it can be? 10. 10 times 2 is 20. 20 minus 20 is 0. If x is 10, you know what? Well, I'll just say it like that. If x is 10, you have no box. Does that make sense? No? Okay. You see how I have...
Because there would be no...
Yeah. You see this dimension is 20 minus 2x?
There'd be no width.
So if x is 10, this would be 20 minus 20, and I would have no width, just like Houston said. And if you have no width, that means you have no box. Like if width is 0, you know what I mean? So based off of that, because of this, you see this and this, you can say this right off the bat. Volume at 0 equals 0. Volume at 10 equals 0. Child, so what does that mean? Okay. We're rookies, so I would still like for you to verify. But if I get a critical number between 0 and 10, that must be my absolute max, because at the two extremes it's 0. Does that make sense? Now, guaranteed the derivative is going to change from positive to negative at that restriction. But just make sure, because of my restriction, if I get one number between 0 and 10, that has to be a max. Cool or not? Okay. Now, maybe it's factorable, maybe it's not. What I'm going to do, I'm just going to type this right into my calculator and just see where I cross the x-axis. Does that make sense? All right, so here we go. I'm taking my calculator. And as a matter of fact, we'll even be able to see the derivative where it changes from positive to negative. Give me that derivative again. What was it? 12 x squared minus 180x plus 500. Okay, so everyone get to here. Don't worry, we're going to help you. I'm only looking between what and what? 0 and 10. So go to window, 0 to 10. By the way, I used to solve this with the quadratic formula, but now I just think we should just use the calculator. 0 to 10. And then my y min, I just care about where I cross the x-axis. So you can go negative, you know what, let's go negative 10 to 10. That's actually, you probably won't see, but you're going to see the line coming from the top. All right, push graph, y scale by 0.5. It doesn't matter, y scale. And then there it is. Notice that it does come from the top to the bottom. Chop, I want to see it. I want to see it. Okay. Well, remember where you started at 500? So there, if you want to see it. Okay. All right. I'm going to go back to my window. 10. All right. Tell the calculator to find that max, or to find that 0. Second, calculate number 2. Left bound, I don't know, 1, 2, 3. I'm just going to push 3. 3, enter. Right bound, that's a 4 over there. 4, enter. Do you guys see how I did that without using the cursor? When it says guess, I'm already between 3 and 4. If there was multiple, you would go to the one closest. Just push enter. And then there it is. Cool or not cool? All right, so here we go. I'm going to write v prime equals 0 when x equals, and I already forgot the number. What is it? X store alpha a 3.6811. 3.6811. And what do they want? Do they want the volume? Okay, volume. Volume at 3.6811 is, and I guess I'm just going to put the equation that I had here from the beginning. So x, 20 minus 2x, 25 minus 2x. So y equals x. Plug it into which one? You can. You're talking about the original volume that we got, like once we multiplied it? Yeah, you can. You get the same answer. Matter of fact, let me go ahead and put 20 minus 2x here. Because I think it wants the dimensions. 25 minus 2x. Okay. So here it is, guys. I got my volume expression in y1, my width in y2, and my length in y3, because I think my height is x. That makes sense? All right, here we go. So I'm going to go to my home screen. I already saved it as A. So I'm going to go alpha trace y1 at A. So there it is. And let me get my width and length. Alpha trace y2 at A. And alpha y3 at A. So there it is. Volume, width, height, or width, length, and then the height is just x. So V, I already forgot that number. 866. No, 820.528. 820.528 cubic units. So they give me inches, cubic inches.
So we plug it into the original equation.
Yes, because the original equation was my volume. You know what I mean? You could have also plugged it into this one. You should get the same answer. And if you don't, let me know. And dimensions are, so let's do length by width by height. So length is, let's see, which one's length? Y2, 12.637. 12.637 inches by height or width 17.6376. Put units whenever applicable. 17.6376. 6376 inches by 3.6811 inches. And if you multiply those three numbers, you should get that number there. Whew. What'd you guys think? Not bad, right? Oh, yeah. A is 3.6811. You know what I mean? I put that in my calculator right there. All right, guys. Let me see what else we got left. I think we'll finish this tomorrow on lab. Is that okay with you guys? We have a delta just so you can get some practice. At least do the level 1, and then the level 2 we can do tomorrow. But at least start with the level 1, and we'll do the rest tomorrow, guys.